Arch Linux has always carried a reputation for doing things differently, often pushing ideas that later influenced the broader Linux ecosystem. When the Arch Linux team announced that their official WSL image is now fully ensuring bit-for-bit identical builds using archived repositories and normalized time, it marked a significant milestone not just for Arch users, but for the entire conversation around trust, transparency, and modern Linux distribution practices. To truly understand why this matters, it helps to step back and explore what WSL is, why Arch Linux on WSL is important, and what reproducible builds actually mean in practice. Windows subsystem for Linux, commonly known as W, fundamentally changed how developers and power users interact with Linux on Windows. Instead of dual booting or running heavy virtual machines, WSL allows Linux distributions to run natively alongside Windows, sharing resources and integrating deeply with the Windows environment. Over time, WSL evolved from a compatibility layer into a powerful platform that many developers rely on daily. Official WSL images provided by Linux distributions became the standard way to ensure reliability, security, and consistent behavior across systems. Arch Linux's official WSL image, therefore, represents Arch's philosophy delivered directly into one of the most widely used operating systems in the world. Arch Linux itself is known for its rolling release model, simplicity, and transparency. Unlike many distributions that hide complexity behind graphical tools and predefined workflows, Arch expects users to understand their systems. This expectation has always extended to the way Arch is built and delivered. When Arch talks about reproducibility, it is not just a technical feature, but an extension of its core values. Reproducible builds mean that if two people build the same software from the same source, using the same instructions, they should end up with identical binary results, down to the last bit. This concept is crucial in a world where supply chain attacks, hidden backdoors, and compromised build systems are real threats. The idea of making the Arch Linux WSL image fully reproducible addresses a long-standing challenge. Traditionally, building a Linux image, especially for something like WSL, involved many moving parts that could introduce variability. Build timestamps, package mirrors changing over time, file system ordering, compression differences, and metadata variations all made it difficult to guarantee identical results. Even if the same process was followed twice, the output could differ slightly, making verification impossible. By focusing on archive repositories and normalized timestamps, Arch Linux has effectively eliminated many of these sources of randomness. Archived repositories play a critical role in this process. Arch Linux is a rolling release distribution, which means packages are constantly updated and old versions are replaced. While this is excellent for staying current, it complicates if a build today pulls packages from live repositories and a build tomorrow does the same, the versions may differ even if the build scripts are unchanged. By using archive repositories, Arch ensures that the exact same package versions are available indefinitely. This freezes the package state at a specific point in time, allowing anyone to rebuild the WSL image later and still obtain identical results. Normalized timestamps are another subtle but extremely important aspect. Many build tools embed timestamps into files, archives, and metadata. These timestamps can differ depending on when and where the build is performed, even if everything else is identical. By normalizing timestamps, Arch ensures that all time-related metadata is consistent and predictable. This might sound like a minor detail, but without it, bit-for-bit reproducibility is impossible. Normalized timestamps remove the last traces of environmental variation, making the final image mathematically identical across builds. The result of combining archive repositories with normalized timestamps is a WSL image that can be independently verified by anyone. A developer, security researcher, or even a curious user can take the official build instructions, rebuild the image, and compare it to the officially distributed one, if the hashes match exactly. It provides strong assurance that the image has not been tampered with and that it truly represents the published source. This level of transparency is rare and increasingly valuable in today's software landscape. For developers using Arch Linux on WSL, this change might feel invisible at first. The day-to-day experience of using Arch on WSL remains fast, minimal, and flexible. You still get Pacman, the Arch user repository, and the familiar Arch environment running seamlessly inside Windows. But under the surface, the trust model has fundamentally improved. When you download the official Arch WSL image, you are no longer relying solely on trust in the build infrastructure. You now have the option to verify that trust through This move also aligns Arch Linux with broader efforts across the open source world. Projects like Debian, REP, ROD, UCIB, LE, reproducible-builds.org, and various security-focused initiatives have long advocated for reproducible builds as the foundation of software integrity. By applying these principles to its WSL image, Arch demonstrates that reproducibility is not just for core packages or niche security projects, but for real-world user-facing distribution images as well. It sends a clear message that convenience and security do not have to be mutually exclusive. There is also an important educational aspect to this development. Arch Linux has always been a learning platform for many users. By making its WSL image reproducible and documenting the process, Arch provides a practical example of how reproducibility can be achieved in complex systems. This can inspire other distributions, container images, and platform integrations to adopt similar practices. In an era where container images, cloud snapshots, and pre-built environments are everywhere, reproducibility becomes a powerful tool for accountability. From a security perspective, the implications are significant. Supply chain attacks often exploit opaque build processes. If users cannot reproduce a build, they cannot easily detect whether a malicious modification was introduced somewhere along the way. Fully reproducible WSL images reduce this risk. While reproducibility alone does not prevent all attacks, it dramatically raises the bar. An attacker would have to compromise the source, the build instructions, and the archived repositories in a way that still produces identical outputs, which is far more difficult than slipping something into an unverified build pipeline. This development also strengthens Arch Linux's relationship with the Windows ecosystem. WSL is widely used in professional environments, from software development to cybersecurity research and DevOps. By offering a reproducible official image, Arch positions itself as a serious, trustworthy option for these use cases. It acknowledges that WSL is not just a convenience tool, but a critical part of many production work where reliability and verifiability matter. The technical work behind this achievement should not be underestimated. Ensuring bit-for-bit identical builds requires deep understanding of build systems, file systems, compression tools, and metadata handling. It involves auditing every step of the image creation process and eliminating sources of non-determinism. This kind of effort reflects a long-term commitment to quality rather than a quick feature addition. It is a reminder that some of the most impactful improvements in software are invisible to most users but foundational to trust. For the broader Linux community, this move reinforces the idea that rolling release distributions can still achieve reproducibility when designed carefully. There is a common misconception that reproducible builds are only practical for fixed release distributions with long-term support cycles. Arch Linux's approach shows that even with constantly changing packages, reproducibility is possible by capturing and archiving specific states. This challenges assumptions and it opens the door for more innovation in how rolling distributions manage security and verification. In practical terms, users who care deeply about security, compliance, or academic research now have stronger guarantees when using Arch Linux on WSL organizations that require verifiable software. Environments can point to reproducibility as evidence of integrity. Researchers can cite exact builds knowing that others can reproduce their environments precisely. Even hobbyists benefit indirectly as these practices contribute to a healthier and more transparent ecosystem. At a philosophical level, this change reflects the evolving nature of Linux itself. Linux is no longer just an operating system for servers or enthusiasts. It is embedded in desktops, cloud platforms, containers, mobile devices, and now deeply integrated into Windows through WSL as Linux reaches these new contexts. Expectations around security, trust, and reproducibility increase. Arch Linux's fully reproducible WSL image is a response to these expectations, proving that open source principles can scale to modern, hybrid computing environments. Ultimately, the decision to make the Arch Linux WSL image fully reproducible is about empowering users. It gives them the ability to verify rather than assume, to trust through evidence rather than reputation alone. It aligns with the original spirit of open source, where transparency is not just a slogan but a measurable property. While many users may never rebuild the image themselves, the fact that they can is what matters. As the software world continues to grapple with issues of trust, security, and accountability, developments like this set important precedents. Arch Linux has shown that even in complex integrations like WSL, reproducibility is achievable and worthwhile. It demonstrates leadership by example, encouraging others to rethink how they distribute and verify software. And in doing so, it reinforces the idea that the future of Linux, whether on bare metal, in the cloud, or inside Windows, should be built on foundations that anyone can inspect, verify, and trust.